So the topic of our discussion on QT today is actually on regression and correlation. Now, there are two items there which you can see in this topic, and we are talking about the two of them because in a way, they have some relationship between the two. So we shall start by understanding what regression is all about. After we have understood what regression is, what regression is all about, then we shall proceed and discuss correlation as another area of study within the same topic. So within this topic, there are two sub-items which we shall have to understand each at a time. Now, the first is regression. Now, when we talk of regression, the regression analysis is also known as method of least squares. It's also known as method of least squares. So it is a mathematical approach where we basically establish a linear equation between two variables, that is independent variable and a dependent variable. So the independent variable, we denote it by by letter y, while so this is a dependent. So the dependent basically means the variable that depends on the other. Dependent variable, we denote it by y. Our independent variable, we denote it by x. So regression analysis basically tries to establish a linear relationship in form of an equation of y is equal to a plus bx. So we want to establish a linear equation, linear relationship between the two, y and x, and y we have said denotes the dependent variable and the x is independent. Now, dependent variable is that variable which depends on the other. So the value of the dependent variable will change or decrease depending on the value of the other. So the other value basically is what we are referring to as independent variable. So in this case, the equation should finally, the linear equation or linear the line should actually be in the form of y is equal to a plus bx. So in this case, a and b are actually constants. So for you to be able to approach, formulate an equation, you must basically get the values of a and b. And so the values of a and b, we obtain them by use of a formula. So a formula for a is simply a is equal to n summation of xy minus summation of x summation of y over n summation of x squared minus summation of x squared. So that is how you will get a. Of course, remember we shall have obtained the value of x and y. We shall have basically have known what y is and what x is in the context of being one being dependent variable and the other being independent variable. So b, which is another constant, we get it by, of course, this is the b. This is the b. So a, we get it by summation of y over n minus b summation of x over n. So in this case, we have two equations there. There is a b and there is basically a. Now this, then we find the values of the two, and then we substitute them in the equation y is equal to a plus b x. So in this case, you can see that for us to be able to get a, we must first this b that we actually need to use in obtaining the value of a, and therefore it is important that we first get the value of b before we can proceed and get the value of a. Now in this case, suppose you have two data. We have x and we have y, and I'm going to be. Let's suppose that these are the units of production, and this is the cost in shillings. So this is the cost in shillings. So in this case, let's say at 20 units, we have a cost of, let's say, 100, and at 30 units, we have a cost of, say, 150. So at let's say at 50, we have a cost of, say, let's say we have 200. So essentially, what now you want to know, this is the x, the independent variable, and y we have said is actually the we want to establish the equation in the form of y is equal to a plus bx. So you have your values there. So what the values are you going to get finally will be dictated by the formulas, the two formulas that you have there. So you can see we need xy for us to be able to get b. We need xy, and xy, therefore this is x and this is y. It means we must have a column of xy. We also need, of course, we are able to get summation of x simply from adding all this. So 20 plus 30 plus that is 100. So we shall obtain the value of the summation of x. Also, summation of y, we just add this 100 plus that. This is 250 plus that is 450. That is the summation of that. Then the xy also we need. You can see we also need x squared. So x squared here, it means we shall have another column x squared. So the summation of y you can be able to get directly from there. Summation of x, we are able to get directly from there. And n is the number of observations. So we are dealing with the 1, 2, 3. So n becomes 3 in that case. So in this one case, x times y here, it is 2,000. This times that becomes 4,500. This times that becomes 10,000. And then you are able to add again. So 2,000 plus 4,500, 6,500 plus that, 16,500. Then you come there and actually you get this, you square the values of the value of x. So 20 squared, that gives you 400. 30 squared gives you 900. 50 squared gives you 2,500. And so you add those, you add 400, 900 plus that. This is 1,300. 1,300 plus 2,500. That gives you 3,800. So from this, then, this is the sum of x. This is the sum of y. This is the sum of xy, and this is the sum of x squared. So your work is basically to substitute these values in the formulas that we have basically obtained, the formulas that we have for a and b. So you can see again, we cannot start with a because we need the value of b in obtaining a. So we shall start with b first. And our work is just to substitute the values that we have, and we have also the 3, 1, 2, 3, 1, 2, 3. So we are actually considering 3 items. So we have 3 times xy. Xy is 16,500. 16,500. We get that what it is. Then we also have summation of x is this times that, which is 100 times 45 times 450 times 450. So simply remember what we are saying: summation of x, summation of y. So it summation of x, summation of y. So it is summation. This is the sum of x, which means the additions of x and the additions of y. Now, then down there we have n, which is 3 times x squared. The x squared, the sum of it is 3,800. So this is 3,800. Then minus summation of x is in brackets. So don't confuse this with x squared. Here you can see the sum of x is in bracket, and therefore what happens is that the sum of x is this 100. So it is this 100 which is squared. So the sum of x is 100. So you work out your values, and you are able to obtain what they are. So just a minute. Now we proceed basically in the computation of what. So we have our values here. We have 3 times 16,500. We get 49. This is 49,500 minus. This is obviously 45. That. So over 3 times that. 3 times 3,800. That gives you 11,400 minus 100 squared. That is that. That is 10,000. So finally, you'll be able to get, this is 4,500 over, this is 1,400. So you divide the two, 4,500 divided by 1,400. You are able to get around 3.2. So the value 3.2 is the figure 3.2 is actually the value of b. So once you have obtained the value of B, you can then proceed and get the value of A. Now, the value of A, how do we get it? We already know the formula. A is obtained by summation of y over n minus b summation of x over y. So in this particular case, the sum of the summation of y, already we have it there, it's 450, so it will be 450 divided by the 3 because the items were 3, minus b, which you got to be 3.2, so it will be 3.2 times the sum of x, which is 100, all this also divided by 3. So finally, this will come to this 3 divided by that becomes 3. This is 150 minus that is 3.2 times 100 divided by 3. So this gives you 106.7. So if you subtract the 2, you will be able to get 150 minus 106.7. That gives you 43.3. So now you have the values of A. You have the values of A and B. So because we have said finally your equation, because you wanted the linear equation, usually should be in the form of y is equal to A plus bx. Now A is substituted by the one new value, which is 43.3, and B was actually 3.2, so that the equation will actually be y is equal to 43.3 plus 3.2x. So with this being the linear equation for the two values there, for these values, then you are able to do a prediction on y if you are given x, or you are able to do a prediction on x if you are given y. So when you are dealing with the regression analysis, which is also referred to as the method of least squares, you must endeavor to have your equation in this manner. So once you have known that your equation should be in the form of y is equal to A plus bx, now you have to understand how then do you go about getting A and how do you go getting B. I've given the formula for getting B as this one and for getting A as this one. But we have understood that for us to be able to get A, first we have to get the value of B because we are using the value of B somewhere within the formula of A. So first we get the value of B in the manner that we have seen, after which then we proceed and get the values of the values of the other one. So once we have the values of A and B, we simply come and substitute those values in that. So in the equation, so that the final equation is y is equal to 43.3 plus 3.2. So you can see this is a constant, it's not changing. And this is actually also a 3.2 is a constant, is the coefficient of x here. So it means that the value of y, in this case, we call it dependent because it will depend, it will increase or decrease depending on what the value of x will be. So when the value of x increases, obviously, it will have a positive effect on y, so such that the value of y will also be increasing. But if the value of x decreases, obviously, the value of y will also be decreasing. And that's why we say y is a dependent variable. It depends on another one. And that's why you call it dependent variable. But x is independent. It does not depend on the other variable. So that's as far as linear regression. We call it linear regression or regression analysis is concerned. So you can either use this linear regression because it's actually a line, it's a function, or we call it a least squares method. Now we proceed to what we call correlation. Correlation. Remember, we have said the two are connected. Linear regression or least squares tries to establish a straight line or a linear function between two variables, and the two variables being dependent and dependent, those which we refer to as x and y. Now, correlation basically implies some form of interrelationship, between the two variables. And the variables here actually are given. So we want to establish whether the two variables are related. So there are two approaches in which we are able to, which we use in establishing the degree and the nature of the relationship. We are talking about the nature the nature of the relationship being revealed by the same, because it will tell us whether it is positive or negative. If the value of the correlation, correlation coefficient is negative, that is to show that the variables move in the opposite direction, which means if one increases, that's the other one decreases, and also the other way around. And if it is positive, it shows that they are moving in the same direction. So if one increases, the other one also will increase. If you are a farmer, you can apply, if you apply enough fertilizer, then basically that may lead to high yield. So they are actually moving in the same direction, and we say that they are positively correlated. So correlation will tell us the nature of the relationship, is it negative or positive, and also the extent of the relationship. Is it high, is it low, and so forth. And so for you to know that your answer is correct when you're determining the correlation, it should not exceed, it should be not exceed either positive 1 or negative 1. So we want correlation. And basically, we had said that correlation denotes some interrelationship between two variables, and the two variables are basically x and y. And so I've said your answer, the correlation will tell us two things: the nature of the relationship. Is it negative or positive? It is negative when the two variables given, they move in the opposite direction. If one increasing, the other decreases, vice versa. And it is positive when they are moving in the same direction. It means if one is decreasing, the other is also decreasing. So the value of your value should be less plus or minus 1. So it should either be less than that, but not, it should be between 0 to this. So the value should actually be between 0 and that. So if you get a, that is that. The value of the correlation should be between 0 and plus or minus 1, as I've said. And as basically said again, it shows the nature of the relationship and the extent of the relationship. Now, we have two approaches which we use in determining the correlation. And the first one we call Karl-Pearson coefficient of correlation. It is denoted by small letter r. And the other one, we call it Spearman's rank correlation. So there are those two. And the exam will actually specify which one you're supposed to use. In Karl-Pearson, and of course, the Spearman's rank correlation, it is denoted by letter R, the capital R. So either those, so where the items are in form of a rank. For example, if you do an exam is done, let's say 2 exams are done, physics, let's say QT and business law are done. So we rank the students in QT, and also we rank them in law. So we want to see the nature of the correlation between the two. Then there we shall be using the Spearman's rank correlation. So this one is used where the items are actually in some rankings. Now we start with the first one, and we have the Karl-Pearson coefficient of correlation. And here again, this is R, X, and Y. The variables, the two variables which you want to see, how are they related? Are they negatively related? Are they positively related? And if that is the case, and what is the degree of that relationship? So we get this. We got the value of this correlation by the R is equal to n summation of x y minus summation of x summation of y into bracket over n summation of x squared minus summation of x into bracket squared. Then you have that bracket down there. Then again, n summation of y squared minus summation of y into bracket squared. Then again, all these two, you multiply those. You work out this bracket and you work out this bracket, and you have the square root of these values. The values down there, you get their square root. So this will then tell you whatever you get here should really not be more than 1, or whether a negative or positive. So how do you get Rn, number of observations, summation of xy minus summation of xy, summation of xy minus summation of x, summation of y, over n summation of x squared minus x in bracket, summation of x in bracket you square. All this you work out first, and then after that you work this other bracket. Remember, you shall have known what x and y is. Y is always a dependent variable. The value of y depends on the other. So we may wish to see how do we obtain it practically. So suppose we have y and we have x, and of course let's say this is x can the values can be anything. So let me have a practical question to demonstrate the same. So this question you've been told, the following data shows the ages and weights of 10 employees. So we have the weight, so we have ages and we have the weight. So this is the age. The weight is 25. This 40. This 24. So this one is 55. This is 70 and 50. So we want to leave it at that. So we want to determine the relationship, the correlation between the two. So what we have is that we are guided by the formula. So again, we need x, y. So we shall take this to be x, and this is y. So remember, where you have items there, and you have not been shown which one is x and which is the y. You are to take the first items as being x, and the next being y, with the procedure x, y, z. So x being the first one, and the y being the other one, unless you have been specifically told which value are x's and which values are actually y. So in this particular case, we need xy, so we shall have another column there, xy. You also need y squared somewhere. You also need x squared somewhere. So we shall be having those values. So remember, whatever we must have to compute must basically be determined or guided by the formula in question. So we have our xy will be 25. 25 times 55. 25 times 55. So this gives you 1375. That gives you 1375. 1375. We have 40 times 70. This gives you 2800. We have 25 times 50. 25 times 50. This gives you 1250. Again, we have y squared, which is this 55 squared. 55 squared, that gives you 30. 25. We have 70 squared, which gives you 4900. We have 50 squared, gives you 2500. We have x squared. X squared is actually 25 squared. 25 squared, that gives you 625. Then we have that 40 squared gives you 1600. And 25, this also gives you 625. So you simply have to add this up. So we have, this is 65, 70, this is 90. This is 105, 175. So the sum of this is 1378 plus 2800 plus 1250. That gives you 54, 5428. Then we have 3025 plus 4900 plus 2500. That gives you 425. Then finally we have 625 times 2, that is that, plus 1600. So this you get 2850. So once you have those, now you just substitute them in the formula that you have seen. We have said that Karl Pearson coefficient of correlation is given by n summation of xy minus summation of x summation of y minus summation of x summation of y over n summation of x squared minus summation of x you square. Then we have that bracket there. We shall work it out. Then we have n summation of y squared minus summation of y. We square it. We also work this bracket out. And then we shall get the square root of that, which is the square root of the sum of that. So the square root of the sum of this bracket and the product of this bracket and the product of that bracket, I mean. So we proceed. And of course, we know there are 1, 2, 3. So we're actually considering 3 items, and therefore x is 3. So we have 3 times. So 3 times xy is times 54, 28. Then minus xy, summation of x, summation of y, 90. 90 times 175. That gives you 750. So you work that out. Then down there again, n x squared. So 3 times x squared, summation of x squared, x squared is actually 2850. So 2850 minus x squared, that's 90. 90 squared, that's 8100. So you work out that bracket, and also you work the other bracket. That's the other bracket. This is n, which is 3 times y squared. Y squared is 10. So 3 times 10, 425. That gives you 31, 275. Minus summation of y, summation of y, the sum of y is actually 175. You square. So 175 squared. 175 squared, you get 625. So you work out this, and finally you'll have to get the square root of this, which is down here. So we proceed with our working from down there. You can say this is 3 times 54, 28. That gives us 16. 16 to 84 minus 15. 750, that is 534 over, that's the sum of, that's the product of that which is up there. Then down there we have 3 times 28, 50, that gives you that, minus 81, 100. So you get there 450. 450 is the product of that, times, because this denotes multiplication. We work out this bracket, we also work out this bracket, and then we multiply. So that is 31, 275 minus 30, 625. So that gives you 650. So you have times 650. So you get the square root of that. So it will be 534 over square root of 450 times 650. So that is the square root of that. So just a minute. This 450 times 650 is equal to, is supposed to be 29 to 500. You get the square root of that. So it is 534 over, that gives you 540. So it is 540.8. So 540.8. So if you have divided 2, be able to get 534 divided by 540.8. So you are able to get 0.987. So you can see 0.987 shows that there is a high degree of positive correlation between the two. That shows that when one variable increases, it will also lead to the increase in another variable and vice versa. So that's how we get the correlation using Pearson. So in the Pearson, we have to have our items there. We have to identify which one is the X and which one is the Y. And as I've said, where there is no indication as to what is supposed to be X and what is supposed to be Y, you take the first items as the X and the next one as the Y. So after that, you apply the formula that we have seen here, we have indicated there, and finally you come at the answer, and this answer will tell you the nature and the extent of the relationship. In this case, you have seen the answer is positive, which means the two items moving in the same direction. So if you are to interpret, it simply means that when the edge is low, the weight is also going to be low. When the edge is high, the weight is also going to be high, and this is actually what is shown by that. So that is Carl Pearson coefficient of correlation. I've demonstrated how we can actually go about it and how basically to interpret the same result. Now we proceed to the next, and that is the second one. And I've said it's called Spearman's rank correlation coefficient. And I've said the Spearman's rank correlation coefficient is denoted by letter R. And I've said it is only applicable where the items under consideration are actually in some form of rankings. So in this case, we apply the formula 1 minus 6 summation of D squared over N into bracket N squared minus 1. So in this case, the D is actually the differences between the rankings, N is the number of observations. Now, I'll be very quick. So suppose we have two subjects there, and I've said we have maths and we have, let's say we have English. These are the subjects. And suppose we have only 5 students in this class. So we have A, we have B, we have C, and we have D. So suppose A was number 1 in maths, but in in English, it was number 3. B was number 4 in maths, but in English it was number 2. C was probably number 3 there, and it was let's say it was number 1 there. So this was number 2, and this is 4 is remaining there. So I'm just saying basically these are the rankings. So remember that for rank correlation, there are two possibilities. Either the items you've been given are already ranked. So if they are already ranked, it means you'll be seeing the 1, 2, 3. Like this one, we have four candidates, and you can see number 1 is this in maths, number 2 is D is in D, number 3 is C, and number 4 is B. Same way, when it comes to English, you are able to see that they did a test, and C led this group, being number 1, followed by B. Then number A is was number 3 in English, and then the person who came last was actually D. So they are in some form of rankings. So where they are ranked, then you just simply go direct and obtain the difference. And the difference here is 1 minus 3, that gives you -2. 4 minus 2 gives you 2. 3 minus 1 also gives you 2. This minus that gives you -2. Now use D squared. D is actually the difference between the rankings. That difference is between the rankings. So D squared, this becomes 4, this becomes 4, this becomes 4, this becomes 4. So if you are to add 1, 2, these are 16. Now you come and apply it in your formula. So in this case, it will be 1 minus 6 is a constant. Summation of D squared is which is actually 16. So D squared is 16. So times. So it is a summation of that, which is 16 over. And how many items are we considering? 1, 2, 3, 4. There are 4 candidates. So it is over 4 into bracket that 4 squared minus 1. So this translates to R being 1 minus 6 times 16. So 6 times 16, that gives you 96 over 4 squared is 16. 16 minus 1, that is 15. So 4 times 15. So 4 times 15. So it is 1 minus, so 96 over, this is 60. So 1 minus, so this is 96 divided by 60. That gives you 1.6. So it is 1, this is negative 0.6. So the rank correlation coefficient here is 0.6, and it is negative. So that negative shows that they are moving in the opposite direction. That is to show that if a student performs well in one subject, he is likely not perform well in another, because negative shows the nature of the relationship. If you perform well in maths, you are likely to perform poor in the other. And if you perform poor in the other, you are likely to perform well in the other. And that's why that's what is explained by the negative sign. So the negative sign will likely tell us what is the nature of the relationship between the two rankings. That's how it's obtained. Now I've said that for rank correlation, there are two ways. Either they are ranked already the way you've been told here, or you can be told, you can be given items. You can be given items which are not ranked. For example, again, in the same scenario, if at all we had only 3 students, and these 3 students, they did maths and they did also English, and these students are A and B, A, B, and C. And these scored 60% in maths, this scored 20% in maths, this scored 50% in maths. C scored 50%. In English, let's say A scored 70%, B scored for let's say 50%, and probably this scored, let's say, scored 40%. Now you can see, and then you are asked to determine the rank correlation coefficient. So where you are to apply the rank, already you'll be told. So where there is no mention of rank, then you have to go to the first one, which is Carl Pearson. So in this case, the items are not ranked. And remember, you have to use the rank, the formula for the ranking, which is R is equal to 6 summation of D squared over N into bracket N minus 1. So in this case, if this is the data, you have to rank them. So in this bracket, N is number 1, C is number 2, and this is number 3 in maths. English, this is number 1, this is number 2, and this is number 3. So you use the rankings as we have explained. So 1 minus 1 is 0. 3 minus 2 is 1. 2 minus 3 is negative 1. So squared, the S0 squared is 0, 1 squared is 1, and 1 squared is 1. So this squared, the difference squared becomes 2. So if you are to apply that again, if you have to apply that in the formula, you'll be having, you maintain the formula will be R is equal to 1 minus 6 times. This squared is 2 here over N. There are 3 items, so 3 into bracket, 3 is squared minus 1. So this is 1 minus 6 times 2 is 12. So 3 squared is 9. If you subtract 1, it becomes 8. So 8 times, so 3 times 8, 3 times 8. So this is 1 minus 12 over 3 times 8 is 24. So it is 1 minus 0.5. So it is 0.5 and it is positive. So it means that positive means there are some relationship in the nature, in such a way that if one increases, the other one is basically is also if you score high in one subject, you're also likely to score the high in another one, and vice versa. And if you score low in one subject, you are likely to score low in another one. So really, the correlation will tell us the extent and the nature. Now, in this case, you can see the items are not ranked. We were just given the marks. And because we are using rank correlation, you have to rank them. If they are already ranked, there's no problem. You proceed and obtain your answer. But if they are not ranked, you have to rank them. And then it is these rankings. It is these rankings that now we are using in obtaining the Spearman's correlation coefficient, as we have demonstrated. Otherwise, that is the end of that class. You can enjoy your time.